Scientific notation is in the form of a times 10 to the n power, where a is a number that's between 1 and 10, and n is an integer. And remember that our integers are our positive and our negative numbers. So typically, scientific notation is used for a very large number. And let's take a look at this first example. We have the number 20 million. So if I wanted to express that number as scientific notation, I'm going to take my decimal point, and my decimal point is right after that whole number, and I'm going to move the decimal over until I'm right in front of that digit that's between 1 and 10. So when I move my decimal over, and I'm going to count the places I move it over, I move 1, 2, 3, 4, 5, 6, 7. And so I have the numbers right there. I move 7 spots. So I have 2.0 times 10 to the 7th power, because I moved that decimal place 7 places. So if we look at this next example, I have 68,700,000. So I have my decimal point, and I'm going to count how many places I'm going to move it over. 1, 2, 3, 4, 5, 6, 7. So I have 6.87 times 10 to the 7th power. It's very important to always keep your digits that you have that are actually numbers that aren't zeros. So you really want to show those because those are important to the number still. For our next two examples, we already have a decimal, and this decimal is a little bit bigger, so I can actually move my decimal to the left or to the right. So here's my decimal point, and I'm just going to count how many spaces I'm going to move again. So I have 1, 2, 3, 4, 5, 6. So I have 5.1 times 10. And since I moved to the right, it's going to be a negative 6. For our second example, we have 1, 2, 3, 4, 5, 6. So I have 7.25 times 10 to the negative 7. So let's make ourselves a note of how when it is a positive number versus a negative number. If the decimal point is moved to the left, the exponent is always going to be positive. And if we move our decimal point to the right, our exponent will always be negative. And it's important to note that these rules are for when we are moving from standard form to scientific notation. So for these examples, we need to express each number in standard form. And standard form just means that I no longer want the number to be in scientific notation. So I have 3.201 times 10 to the 6th, and I need to move that into a regular number. Well, my exponent is positive, so when I have a positive exponent and I'm moving to the right, typically a positive exponent would tell me that I move to the right. However, I need my number to go opposite because I'm moving into standard form. So I'm actually going to move my decimal place 6 places to the right. So I'm going to rewrite the number 3.201, and I need to move this decimal place over 6 places. So I have 1, 2, 3, 4, 5, 6. So my decimal place ends here, and then I have all these empty spaces. And those empty spaces just tell me that I'm going to fill those all in with zeros. So my number in standard form is 3,201,000. And I could check that by saying, okay, what happens if I moved the decimal place back over to the right or to the left 6 places? Would I get the same decimal? And I would. For our second example, we have 9.03 times 10 to the negative 5th. Well, I'm going to do the opposite. So since it wants to be negative, I'm going to have a large exponent or a large decimal. So I'm going to take 9.03 and I'm going to move that to the left 5 places. So I have 1, 2, 3, 4, 5. And then I just fill everything in with zeros that are empty spaces. So my final answer is 0.00000903. So let's make ourselves a little note. If I'm moving from scientific notation to standard form, I know that if the exponent is positive, I'm going to move the decimal to the right. And if the exponent is negative, I'm going to move the decimal to the left. Go ahead and pause the video and try these two on your own. So we're going to express each number in standard form, and I see on our first example that I have a positive exponent, so I'm going to move the decimal to the right 9 places. So I'm going to have 6.32, and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Fill in all my spaces with zeros. So my answer is 632. I have 6,320,000,000. For my next one, I know that I have a negative exponent, so I'm going to move to the left. So if I have 4, my exponent or my decimal is right there, so I'm going to move to the left 7 spaces. And fill everything in with zeros. So my answer is 0.000004. When multiplying exponents, I can just follow the rules of learning what I learned from the last 2 sections about exponents. So I can actually, because I have 3.5 times 10 to the negative 3rd times 7.7 times 10 to the 5th, I'm going to rewrite this to say 3.5 times 7, because I'm going to multiply my coefficients, times 10 to the negative 3rd times 10 to the 5th. And when I simplify that, 3.5 times 7 is 24.5. And here I have the same base, so I know that I'm going to just add my exponents. So I get 10 squared and since this number, 24.5, is not in scientific notation, because scientific notation has to be, remember that that number has to be between 1 and 10. So I need to rewrite 24.5 as 2.45 times 10 to the 1st power, because I moved my decimal place just over 1 space, times 10 squared. And then I can simplify, I can combine my bases, so I get 2.45 times 10 to the 3rd power, because I add my exponents. And then when I simplify this, I'm going to get 2,450. It is very important to remember that when we have scientific notation, it is a number point the rest of the digits, because that number has to stay between 1 and 10. Let's go ahead and take a look at another example. So I have 6.5 times 10 to the 12th times 8.7 times 10 to the negative 15th. So the first thing that I want to do is I'm actually going to rewrite it to say 6.5 times 8.7, and then in parentheses I'm going to have 10 to the 12th times 10 to the negative 15th. And when I do 6.5 times 8.7, I'm going to get 56.55 times 10 to the negative third. And remember that I always want my larger number to be that number that's in between 1 and 10. So I'm going to get 5.655 times 10 to the first times a 10 to the negative third. And when I do my product of powers, I get 5.655 times 10 to the negative second. Go ahead and pause the video and try this one on your own. So the first thing that I want to do is I'm going to rewrite is 1.95 times 7.8 times 10 to the negative 8th times 10 to the negative second, and I'm going to get 15.21 times 10 to the negative 10th. And remember that I want my decimal to be 1.521 times 10 to the first, 10 to the negative 10th. And then when I simplify that, I'm going to get 1.521 times 10 to the negative 9th. When dividing scientific notation, I'm still going to follow the same type of steps and rules. So I'm going to take 3.066 divided by 7.3, and then times 10 to the 8th over 10 to the third. And when I simplify this, I'm going to get 0.42 times 10 to the 5th, because I subtract my exponents when I use division. And remember that I want my number to be between 1 and 10. So I'm actually going to move my decimal over 1. So I get 4.2 times 10 to the negative first times 10 to the 5th. And then using product of powers, I get 4.2 times 10 to the 4th. Let's go ahead and take a look at another example. So for this example, I'm going to follow those same steps. I get 2.3958 divided by 1.98. I'm going to multiply that with 10 to the third over 10 to the 8th. And when I divide, my answer is, I get 1.21 times 10 to the negative 5th. And actually, since my number is already in that range of 1 to 10, I can go ahead and leave my answer like this. Go ahead and pause the video and try this one on your own. So we should have set it up as 1.305 divided by 1.45 times 10 to the third over 10 to the negative 4th. And I'm going to get 0.9 times 10 to the 7th, because 3 minus a negative 4 equals positive 7. So I need my 9 to move over 1 decimal place, so I have times 10 to the negative 1 times 10 to the 7th. So my final answer after I use product of powers, I get 9 times 10 to the 6th power.